So we left off on disadvantages yesterday, correct? I know that we might have covered this, but I'm going to go over some you couldn't see the notes anyway, so these are disadvantages other than the dirtiest fossil fuel, the most polluted, right? Carbon dioxide and sulfur oxides, because coal is the worst fossil fuel in that sense. It produces more pollution than any other. But in addition, remember that we talked about the fact that it's going to cause a lot of land problems like erosion, degradation of topsoil. You're going to have possible displacement of ecosystems. Like if we're going to mine in a forest, we got to cut down the forest in order to be able to get to subsurface mining or surface mining. You're going to have water pollution. You're going to have a lot of trace toxic materials from mining that can end up in a body of water. Such as what? Give me 2 or 3 examples of what can end up in our body of water. Tailings. Okay, good. Any waste from mining can end up in and most of them are toxic substances. What compound are we always going to think about when we think of carbon? I mean of coal. Sulfur. Good. Sulfur can end up in your body of water. What is that going to cause?
Acid, acidic,
sulfuric acid or a pH drop in the body of water. Now, what ecological problems, because this seems to continue to be a problem, arise from drop of pH in a body of water? So killing organisms is not an ecological problem, right? So you kill an organism, and ecology means how do you and your environment interact and other species. So if you kill an organism, okay, lowering pH kills an organism, what connection does that have to the ecosystem?
messes up the food chain.
It could disrupt the food chain. Always think of that. That's how simple it is. If not disrupt the food chain, target a keystone predator. A keystone predator can be affected by a drop in pH and can't survive in the body of water. And without a key important organism, it could affect the whole balance of the ecosystem. You need to make those connections, okay? Good. You also want to take into consideration, this is not ecological. This is health related. Mining for coal has a lot of issues, health-related issues. One big topic was black lung disease. So because they were breathing in all of these little particles, they ended up with a lung disorder, hence why they're wearing masks. And then what's this? Sinkhole. What type of mining do you think leads to sinkholes?
Surface.
Where they like clear it out and then it's like
Not open pit.
No.
Subsurface. So if we're going to go underground and we're destroying that, we're destroying the foundation that the ground sits on. And that's how sinkholes tend to happen. And then last thing, and if you notice, these are more all associated with mining, or more, not all, but very associated with mining. You've got something called acid drainage. So if you're not writing this down, please remember you're going to have to watch the videos because this is not anywhere written. It's just a picture. Acid drainage comes from abandoned mine sites. It can come from mining in general, okay? Anytime you mine, you have traces of acid particles that can drain out of the mine site into the land, also be taken in by the water cycle and run off into a body of water. If acid goes into the land, who's directly affected? Plants. And then plants can affect the whole ecosystem because they're the producers, and without producers, right? Okay. Okay, so with all the problems with coal, what are the main problems with coal? They produce sulfur. What else? CO2 and also nitrous oxide. So we really clean coal to help reduce emissions when we burn it. When we burn it, there's a lot of sulfur, and the highest sulfur, because coal has the highest sulfur. There's also carbon dioxide and nitrous oxide. And there's particulate matter, not just during the burning, but during the mining. So this is what you have to know about cleaning coal or clean coal technology, which is real. We're basically washing coal. And there you see, as soon as they get the coal into the plant, they start washing it. And then they put it into these scrubbers. They're called wet scrubbers. So I want you to know that we clean coal by washing it. Then we put it into the wet scrubbers to remove sulfur. You see that word? We add flue gas, water, and limestone. You can never say I didn't tell you. You don't have to know that on the test, okay? We clean coal by adding water, and then we put it into wet scrubbers to remove the sulfur. You also don't have to know what it makes, okay? But it makes synthetic gypsum, which is used to in construction materials. So the walls right there that you have, that's probably a byproduct of coal. Then we also capture carbon emissions during burning. So carbon capture storage, I can't elaborate on the storage part because maybe one of you will in your presentations. So I'm going to leave it at that. All you have to know for this test is that we capture carbon emissions to reduce the emissions in the atmosphere. And then the last thing I want you to know about coal is the fact that we are converting it into gases and liquids. Why do you think we do that? That actually makes a lot of sense. It might be less emissions, but I mean, coal is coal at the end of the day, right? I'm thinking during the process, there'll be less emissions, but also more, I don't know. It could happen. That's not why though. Nope. So coal, we said, has the highest heat potential because it's a solid fuel. So we're converting it into, I'll show you. During coal gasification, we're converting it into synthetic natural gas. And coal liquefaction, we're converting it into synthetic gas or liquid gas, right? Why? As a resource for what? To substitute what? Petroleum and natural gas. At the end of the day, who has the most coal?
We do.
And the world has the largest reserves of coal as a non-renewable resource. So I guess when you're in a panic, what if we run out of the others? Why don't we convert what we have into those others? That's the thought process. Okay? Go. All right, so nuclear. Let's talk about nuclear. Nuclear is like a fossil fuel because it's what? Good, non-renewable. I have to type with you. My guess is as good as yours. Non-renewable. It's found in Earth's what? Look at the picture. Good, crust. Mainly in rocks, okay? The energy comes from uranium ore. And we get it through, if it's on the crust, what do you think? Surface mining. Good. So believe it or not, most rocks have uranium. So let's talk about it a little. Here's the world's reserves or highest reserves. I always give you like the top 3. Australia, I don't even know how to pronounce the next one, and Russia and Canada. Okay? Kazakhstan. Who is the world's largest producer? Lucky us. So 70% of energy in the US comes from nuclear. That's wrong. You don't even have to know that. Yeah, it's France. No, you know what? That came up once, so go ahead and write that. I know it's not. Ours is definitely, ours is fossil fuels for sure.
I was like,
All right, before we go to major uses, oh no, major uses is next. I'm actually gonna skip this slide because I didn't cover this with and I'm gonna go here, okay? So they didn't even get to see this picture, but Why do we use nuclear power? Okay, you gotta think. We up until now, before nuclear, we were using fossil fuels. Why would we want to look for something else? Give me reasons.
Carbon dioxide.
Good. We need to reduce emissions of greenhouse gases. Reduce emissions of greenhouse gases. Or any emissions of toxic chemicals that are causing global air pollution problems. What else? What does faster mean? We are thinking of something to substitute our non-renewable resource. But nuclear is non-renewable, okay? But we're scared we're going to run out of fossil fuels. Let's look for something else, okay? So we're scared of time and running out. Scared to run out. So consider it our first alternative. Nuclear was the first alternative fuel that we thought of. And then this is the main reason. It has super capabilities to produce energy. And I'm going to show you how much in this next slide. And I'll leave you with this. 1 pellet of uranium is equivalent to a ton of coal. If we're going to produce electricity, 1 little teeny weeny pellet of uranium is going to produce the same amount of heat to spin a turbine as an entire ton of coal. And if you want to compare it to other fossil fuels, 3 barrels of oil, which is equivalent to 42 gallons, 1 quart of wood, and 17,000 cubic feet of natural gas. So it's pretty powerful initially, okay? I'll tell you later why.